Okay, so first of all, it's really good to be back physically with all of you. Thanks for the organization for this opportunity. And thank you all for attending. So this talk will be about secure controls in a platform in a cloud age. Yeah. So a bit about myself. I'm Pedro Raminhas. I am a cloud engineer at Philip Morris International. I work at the infrastructure team, and we basically are building a platform where PMI, Philip Morris International, can host all of its digital assets. I studied computer science at Technic. Afterwards, I stayed a few more years in academic research and teaching, so that's what I wanted at that point in time. Then I started working as a DevOps engineer, working with AWS. And yeah, a bit of myself personally, I enjoy sports, watching and playing. I like reading, I listen to podcasts. I'm a foodie and I enjoy general health related themes. And before I start, some important remarks. This presentation does not necessarily reflect the ideas of my employer, just my own. And this presentation heavily targets the following technologies, so AWS and Terraform. So who has worked with this stack? Okay, good. So all of you understand, but the other cloud providers and other infrastructure as code provide the same services. So the agenda for today. So let's start looking into the security approach to DevOps throughout time. Then let's talk about how to apply security to a platform, and then deep diving and taking a look into the security controls that we can apply. So a few years ago, I think you all can relate to this image. We had silos in the companies. So we had the development team that developed the code or the infrastructure. We had the QA team that hosted the tests for the programs or the infrastructure. And we have the operations team, which basically performs operations, monitors the infrastructure in production. As you all here know, we don't like silos, so because if something breaks, all teams finger point to each other, and yeah, it causes a lot of friction in the companies. So that's why we came up with the DevOps culture, where a single team or a bunch of teams manage the whole life cycle of applications. So we develop, we have the QA pipelines, and we manage the infrastructure in production. And then we capture what we have learned in production, and we basically use that knowledge to develop again and start the whole cycle again. But there is an elephant in the room. I think from the title you can guess which team was. Is it so the security guys? Normally in companies, what is the role of security? So we have a set of security architects that basically give some feedback in the development phase. So we are designing, we are building a new system, we identify the vulnerabilities, we create the threat modeling, we discuss with the security, and we agree if we should mitigate the vulnerabilities or not. Then normally in companies, security, it's not, so the team does not act upon the QA environment. But then for the production one, we have the Security Office Center, the SOC team, which analyzes the infrastructure that is in production and checks for attacks, vulnerabilities, etc. in production. And yeah, as I draw here a vertical line, this is an alert for us, DevOps, because we have silos here. So if something breaks, finger pointing, and we don't like finger pointing. Just an example here of a threat modeling because we have it in early stages of development. So threat modeling, what is it? We have we have our system and we have a bunch of scenarios of potential attacks for our applications, and we basically give some scores to certain aspects of it. So the damage of a certain attack, the reproducibility, the exploitability, the affected users, and the discoverability. And there are a scale that you can use to score these threats, and then by the end you sum all up, and you have 5 of them, so the maximum is 50. And then you have a scale here. So basically the example that I gave was, okay, so we have an API gateway that exposes an endpoint and allows to create or delete IAM users. And the attack is to being able to find the API token, so an attacker finds it, and basically it has administrator rights over the API, and it can delete all the users. So this was just an example. I classified all the threats, and it gave me the score of 35. So we can see here that is a high one, a severe vulnerability. So we need to consider for review and resolution soon. But yeah, just for coming to the point that this happens at the early stages of development. But then, as we have DevOps, we also are moving for having a platform, so platform engineering. And in platform engineering, so we have a platform team, and we provide we build a platform, and we provide to the customers a set of APIs. Imagine an AWS account, some Terraform modules, some pipelines that the applications developers can use. And that way, they don't need to know much about the infrastructure, and basically we, as a company, are sure that every application obeys to a set of standards. And here in platform engineering, as you can see, we also have silos. And because we want a platform that is used by a bunch of application teams, the security architect needs to engage in threat modeling with each team that builds the application on top of the platform. And SOC needs to monitor all applications that are built on top of it. And so that's why we wanted to introduce some measures, both in DevOps, so in the pipelines that we are building, and at the platform that we are building, so that we can do a shift left and the application teams can focus on their applications. And yeah, that brought us to DevSecOps. So from here, who has been hired as a DevSecOps? No, okay, so good market niche. Okay. So yeah, DevSecOps, I believe all of us do it. It's to use security in our DevOps practices, so the way we deploy software and infrastructure. And we can basically implement, so we have here a common image, so a developer, the version control repos, the CI/CD pipeline, and we have the cloud provider. And we can divide the measures that we can implement at a platform or a DevOps culture. We can divide them as a proactive and detection and reaction. And the proactive acts on the CI/CD pipeline, and the detective ones and the reactive ones at the cloud provider. So let's start with the first challenge, which is to have security by design. So we want all the code before going to production to basically be analyzed, see if there are some security vulnerabilities in it, and both code from programming languages such as Python, Go, you name it, but also infrastructure as code. We also want to check for poor code quality, and basically avoid doing deployment with vulnerabilities. So for that, we have a bunch of tools available. So I mentioned here some of them. So SonarQube, it supports various programming languages. You have check-OV, which checks for your Terraform code, checks if the infrastructure will have some security vulnerabilities. And yeah, because in your company, you sometimes you need to obey to certain, let's say, to certain standards of governance. You will need to have certain tags, or you don't want any S3 bucket to come to production with the public access enabled. So by the end of your pipeline, you can use the Sentinel policies, which it's some policies that you can develop in code. And yeah, you can check for tags, certain resource types if the S3 buckets have the public access enabled. So yeah, use those. So let's go to the next challenge, which is detection. So if you remember, we have SOC team that monitors all the assets in production. So we moved to, so basically teams are building on top of our platform. So we need to provide SOC the right logging and auditing of what has been happening in our platform and possible security breaches. So when you set up a new organization in AWS, so normally the first step is to enable CloudTrail. So you can check all the auditing, so what has been happened, the access of it. So you can basically get the CloudTrail logs and send them to the SOC team. And yeah, they will create some rules and check if, for instance, the root user has been accessed or not. Another good approach here is to, because normally SOC, it's interested in knowing the certain logs of certain applications. So you can define with them, define some CloudWatch log groups. So for instance, the EC2 ones and the EKS ones, you can define the CloudWatch log groups with them. And you basically provide to your customers a way that, okay, by a tag in the CloudWatch log group, or if you send the logs to a certain CloudWatch log group, it automatically, as you deploy their Kinesis firehose, and yeah, it automatically picks the logs and sends directly to either a S3 bucket from SOC, or imagine a CM system like Splunk. So we are done with auditing and logging. The next challenge will be IAM, Identity and Access Management. This is a pillar of security. So here, yeah, you'll need to define the personas that will access your platform, and yeah, but the general target access model. And here, you as a platform team, you can leverage the security architects in your company, because you need to clearly define the roles of the personas that access your platform, and define which permissions do they have. So yeah, I just stated the read-only access, the administrator, and a developer one. And yeah, this is done with AWS IAM. So the next challenge, it's security automation. So basically you need to have a status, because okay, you have your pipeline, but then you give to your customers an AWS account. Imagine that they don't deploy using the pipeline, they go directly to the AWS console and deploy some resources there. So you need to have some measures to detect it and correct it. So this is done using AWS config. So, and for that you can also leverage your security architects to define which corrective measures do you want to have in your AWS account. So I just put here a simple diagram. It's just, okay, the same scenario, you don't want S3s with public access control lists. So you create a AWS config rule, and whenever someone creates an S3 bucket with that configuration, it triggers a CloudWatch event, triggers a Lambda, and yeah, you can change the bucket. It's ACL to private, yeah. So this is just an example. It's very easy. AWS comes with a lot of rules, predefined ones. So one of them is the ACL private for S3 buckets. Then, as a pillar of AWS, yeah, you need to provide some protection in the infrastructure. So you need to protect compute and the networks. To protect your compute, yeah, you need to reduce the attack surface. For that, it's better if all people that are developing in your platform have instances running at the same hardening. So yeah, you develop some golden images, you provide an hardening script on top of it, and you can apply some service control policies, and basically everyone needs to use your golden images. But you also need to patch your instances, and for that you also have a service in AWS called Patch Manager, yeah, where you can define the vulnerabilities that you patch in your instances. So as a tip here, yeah, so because you are building a platform, give the freedom to your customers to define the maintenance window in which you allow the patches to be done, so that you don't make your application slow or break them. So you can do that using a tag. Then, sorry. Okay, so we were protecting compute. Let's move to protecting network. For that, AWS has a lot of network firewalling solutions. Yeah, one of them it's the WAF and also the Shield. So the Shield, here you have your application here running. You have some normal users, and you have an attacker that runs a bunch of nodes and pings your application. And so the attack is to make your application overload, and it cannot accept more requests, so it goes down. It's a denial of service. So you can use AWS Shield. It detects automatically those attacks and detects on layer 3, 4, and 7. WAF, it's more for layer 7. Yeah, and it's for attacks such as including in the request some SQL injection attacks and other type of attacks to web applications. But for other layers, you can use the AWS Network Firewall or other solutions such as the Palo Alto networks. So just to conclude, what is the place of a security team in a platform engineering? So this is what was before. So the security architects would interact with every application developer, and the SOC would need to monitor all the applications developed. The future will be those architects and the SOC will be embedded in the platform engineering team. So some of them will be some DevOps with security expertises. Some of them will act to design the platform and how you allow the customers to consume it. Yeah, but yeah, this is the future, to embed security in the platform. So I would like to finish with some lessons learned. So the first one, it's be careful with AWS config. Be careful with what you automate. Because imagine automating key rotation or users that are not accessed for X amount of time, and you just delete those or you rotate the key. Yeah, it can bring some damage to your company because someone wants to access it later and they don't have the user or the key has been rotated. So be careful with that. And yeah, be careful with the measures that you put on the pipeline, because yeah, you can block some teams, some application teams, because you don't know. Okay, so you need to you know that some application teams have more maturity and more technical skills, and you have teams that do not have them. They are less mature. So probably they won't know how to apply the measures, or to imagine that you enforce some tagging scheme, so they wouldn't know how to do that in Terraform. So be careful, do not block teams. Don't enforce right away. So imagine that you enable SonarQube, just put it in auditing mode, so don't go for enforce. Let the customer check their errors and fix them. And yeah, as a final remark, yeah, communicate your changes and enforce the changes per environment. Yeah, the key takeaways from this talk is to listen to your users' feedback, do incremental changes, communicate the changes for your application developers, do some knowledge sharing sessions, help them, and document everything from the customer perspective as well as a technical perspective for your platform engineering team. And yeah, that's all. So, questions?
I have a lot of questions. This is your point of view, or is your what your team and your company do or aim to do?
It's my point of view, yeah.
Because you centralize CI/CD pipelines, security issues, security architects in a single team. I agree with you, but it's sometimes very difficult to implement in the companies because you are bad cup, because you are sand in the rails. If it was your company, I would be interested to talk to you after this. And I forgot the other questions. I will come back again.
But I can do a follow-up question on this. Okay, go ahead.
No, continue.
No, go.
No, it's a different topic. Is that,
Okay.
Continue.
Okay, so following up that question, what would you recommend on doing this shift left, on pushing the knowledge or pushing more the security culture to the product team? So I do see often that the pipelines are super well protected. We have all of the reactive on the cloud, but what can we do in order to bring the engineers that are on the product teams aware of what they do, how they code, handling properly FSCL injection, GWT tokens the right way, think about security in another level's perspective?
I think it comes to the point of doing more knowledge sharing sessions between the platform engineering and the teams, and basically providing training periodically, have documentation. That way their security maturity will evolve, I believe. I think that's the way.
I do see a lot of training in knowing what a risk indicator is, a risk issue is, but not generally in the coding aspects of things. Do you know if there is any good material out there in order to learn this, that it can be easily scaled to the engineering
from
teams?
the code perspective?
There's some companies that do courses mandatory courses when you join a company, or Udemy that makes you, for example, understand these things. Some of them only tell you to go through cloud best practices. Very few put security best practices in that training, for example. But there's a few things that can be done. Okay, thanks.
In my opinion, in my experience, I implemented, for example, SonarQube, and I used SonarQube results and knowledge. Oh man, come on, and look at these bad approaches, bad codes, and I was using these results to implement the new culture. Oh, I can use this approach to improve my code style, for example. Because sometimes just collecting results and oh man, we need to avoid it. No, look at this example and these tips from the SonarQube, for example, to change our source code, for example. It is a good idea to create an improvement in a pipeline, for example. It was great in my experience.
Yeah, I think it's a good approach. Yeah, you have the errors that SonarQube gives you, but you don't block based on those errors. It's just for your learning and achieving more maturity. Yeah.
The second question, or did you already?
Here is also not a question. I noticed that nowadays there's an important test to make, that is vulnerability check. So checking for vulnerability during the CI/CD pipeline, just before the build pipeline, because if I've got some vulnerability on my dependencies, probably it won't make sense to continue to the pipeline.
You mean at Git and Bitbucket at the repo level?
at triple level, but if your applications, being Go, Python, wherever, has some dependencies to work, checking for vulnerabilities in that dependencies and not continuing with the other platforms. Nowadays, after that big vulnerability, Log4j. So everybody was kind of nervous checking the vulnerabilities, then blocking them before compiling the application itself. And your security architects probably were as nervous as the other companies.
Yeah, but there are some checks that you can do right away at the repo level before you start your CI/CD. Yeah, those are cool. And you can check the libraries that you are importing. It's a good approach, yes.
Anyone else? Okay.
We've seen I get the main question about and then there's communication with the other teams and application. How is this communication done?
So at the teams that I've worked, we have a team that is more customer centric. Normally, your security team and the technical teams must coordinate with them, and they are used to communicate with the customers. They will help you with documentation, so they are more customer facing. So you will leverage those teams.
Is this something that the other teams can give you the information? Or do you go?
Normally, you need to be proactive as a platform engineering team, so you go to them.
Good question, please.
I think we still have time. The beers are getting more than so.
Thank you. So regarding your current role or the things that you have done, what were the main impactful practices regarding security that you have seen in your team or in the teams that you already worked with?
I believe I think it's from the WAF perspective. So we implemented the WAF. You can use the firewall manager, which is that allows you to deploy to the whole organization. And you start by using that. You will have another layer of security on layer 7. And with that, the teams were not used to think about, okay, so maybe if someone passes me some wrong SQL or with some malicious code, they can execute it. And they basically became more aware of it, of the application 7. Yeah.
Some people saying that your organization is always as strong as its weakest link, and even though no matter how much effort we put into sophisticated security measures, sometimes we're just breached by a weak password. Do you feel that as time goes on and security and talks like this and just professionals in general are more conscious of security issues, that weakest link goalpost is moving? Is it getting a little bit more difficult for that weakest link to be breached, or are we always going to be as vulnerable as just a crappy password?
I believe the weakest link hasn't moved, to be honest, because we are humans, and we want to provide a lot of measures, but if you have a weak password or someone goes to AWS and deploys a new service with some vulnerabilities, you will always have those kind of vulnerabilities. But it's cool. It's cool that us as professionals, because some years ago security was for the security guys and not for infrastructure or the software engineers. And I think right now all of us know a little bit more about security than some years ago. So that's good.
Thanks, Pedro.
Thank you.